Hey everybody, this is Mrs. Fisher. Today we are doing our last set of notes for Unit 1. This is Unit 1, Day 8, and we are going to talk about finance. Everybody usually likes to talk about money. We're going to talk a little bit more in depth about money than we did in Math 3. So this is going to talk more about how to realistically borrow money and save for money, save for purchases. We are going to first review what you did in Math 3. So in Math 3, we talked about compound interest. So that looked like this formula. A equals P, and then 1 plus R over N to the NT. And in that formula, A represented your final amount of money. The number on the left-hand side always represents a final amount. On the right-hand side of the equal sign, the number that is immediately to the right-hand side always represents your initial amount. And then you have a 1, and then you have R, which represents your interest rate that you are going to want to write as a decimal. The N represents the number of times you are compounding your interest. So this will be a number like monthly, quarterly, weekly, semi-annually, something like that. So if it's monthly, then N would be 12, for example. So these two numbers are going to match. And then the last value is T for time. All right, so that should look familiar to you because you did that last year. Another one that you looked at last year was when interest is compounded continuously. So compounded continuously was PERT. Okay, and that should look like some other problems that we've looked at. Continuous growth uses the natural number E. That is how anything that grows continuously is going to grow. So we don't always use the same variables with things that grow continuously. We don't always use A. We don't always use P. We don't always use R. Sometimes we use a K. But the location in the equation is always the same. So again, the number on the left is still going to represent a final amount. So this is final. The number on the right-hand side is going to be initial. R is still rate, T is still time. This E is the natural number E that is in the calculator, 2.71828, and that is stored in the calculator. Okay, so like I said, those we did last year. So quick little examples. Let's say that Joe wants to save for his trip to the moon. He invests $1,000 into an account that pays 3.25% compounded monthly. How long will it take Joe to raise $10,000? All right, so what we have is a compounded monthly situation. So compounded monthly is your key phrase here. So that tells you are going to use the first formula that we wrote down. So in that formula, we've got A equals P, 1 plus R divided by N to the NT. And so we want to substitute our values into that formula. So we've got A, our initial amount. Sorry, A is our final amount. That's $10,000 equals P, our initial amount of 1,000, and then 1 is still 1. Our rate as a decimal is 0.0325 divided by N, which is 12, because monthly, there's 12 months in a year, and then to the 12 times T. So to solve this, we are solving for a variable which is in the exponent, so you're going to have to use logarithms. All right, so we're going to have to solve this like we've been doing in class. We are going to have to isolate the term that has the exponent. So this guy right here needs to be isolated. We're going to get this guy by itself. So to do that, we are going to divide both sides by 1,000. All right, so 10,000 divided by 1,000 is going to be a lovely little 10. All of these numbers right here in the parentheses, you can go ahead and combine and put those together. When you do that, get a bunch of decimals after that. So I'm going to store that in my calculator and leave all of that. But for my paper, I'm going to write down just some of the decimals. Raised to the 12t. So now my term with the exponent has been isolated. So from this point, we are going to change to log form. You can either do that by the definition of a logarithm, or you can take the log of both sides. Okay, so either way you want to do it. But in the end, you should get the same thing. So I'm going to take the log of both sides just because that's what I like to do. And when you take the log of both sides, I'm going to choose log, even though I like to do ln, but I'm choosing log because if I have log base 10 on this side, that's going to cancel out there on the left. And then log on the other side. That allows me to bring this power down in front right here. Okay, so we have log 10. I'm just going to rewrite for clarity. We have log 10, and then on the left we have 12t times log of 1.0027, blah, blah, blah. Okay, on this side, log 10, that cancels out. That is amazing. We get 1 equals 12t times log of blah, blah, blah. Whoa, too many zeros. Whoa, not enough zeros. 27 point. All right, and so now we need to solve for t. So we need to get rid of all the other numbers. So divide by 12 and log of 1.0027. All right. So divide by 12 and log of 1.0027. All right, type the left-hand side into your calculator. Please remember to put parentheses around this entire denominator, all of this, please. Otherwise, you're not going to get the right answer. Okay, and we get that it is going to take Joe approximately 70.94 years to save for his trip to the moon. Good luck, Joe. All right, example 2. Let's see, you want to save for a trip to a tropical island. I don't know, I'm not being very creative today. To a tropical island. You deposit $2,000 into an account that has, or that pays, let's say, 2.3% compounded continuously. How much will you have in 2 years? Sorry, that's messy handwriting. I'm using a lot of 2s as well. So, keyword in this one, friends, compounded continuously. So that is your key phrase to let you know that this is a PERT problem. Okay, so we are going to do A equals P E to the RT. All right, 2,000 is your initial amount. 2.3% is your rate. Time is 2. So why don't you pause, go ahead and see if you can get the correct answer. Welcome back. All right, so you should have A equals 2,000. E is the E button in your calculator. Rate 0.023 and time is 2. So this should be what you typed in. Please make sure that you use parentheses around your exponent if you've got an older calculator. If you have a newer calculator, it will take care of keeping that all an exponent for you. All right, so you should have gotten $2,094.15. I don't think you're taking that trip anytime soon. So, as you can see, saving in this way is not very effective. So, if you want to actually save money and do any of these fun things quicker, like go to the moon, go to a tropical island, maybe do things that are more realistic for what you might have to do in life, like go to college, buy a car, save for things like living on your own, living in an apartment, needing the security deposit, buying a house one day, things like that. You need to save money a lot quicker than what these type of scenarios will allow for. So that brings us to the real meat of the pre-calculus finance study, and that is something called annuities. Okay, so these just allow you to save money faster. Okay, an annuity is just a more realistic finance model. All right, and so what makes this more realistic is that you make payments. Okay, and that could be payments just to yourself. So if you are saving money, when we say making payments, we say that you can make a payment to yourself, like a payment into an account. If you're borrowing money, that means that you are paying somebody back at regular intervals. All right, so the way that you do these problems is you can use like a crazy formula, which is what we had to do probably 10 years ago. We were still using these crazy formulas 10, 15 years ago. But now you have this great application in your calculator. If you hit your apps button, the first application in there is the finance app, which is pretty awesome. So you want to go to the apps button, and number one in there is your finance app. And that is going to allow us to do all kinds of different problems that will help you kind of model what's going on in real life with some finance stuff. So we are going to look at different scenarios like saving for college, credit card payments, all kinds of things. So for your notes right now, I'm going to just take a minute and write down the stuff that we are going to need to use in our calculator. And then we're going to go through examples in class, but I want to get this stuff written down for your notes, okay? So to do in the calculator. To do in the calculator. All right. So your first step is going to be go to apps. So your apps button. Number 2, select option 1, finance. And then from there, you are going to select option 1, which is called TVM Solver. That stands for time, value, money. This thing saves us so much time from having to do the formulas that we called it the thank you very much solver, but you can call it time, value, money if you want. All right, and once you look at that, there is a whole list of things in there that the calculator is wanting from you. So the next thing is to enter the requested info. All right, so we are going to just write down what that information is. And so it's asking you all this, and we're not going to be able to do this without an example. So that's what we're going to work on in class so that we can talk more specifically about what all this means. All right, so for now, just get this down and I'll write down what everything means, okay? All right, so the capital N here, this represents what the NT represents in the first equation that we wrote down today. So this is the number of times you're compounding your interest times time in years. So times the number of years. Let's write that down. Times the number of years. So when I say number of times compounding interest, that's like if it's monthly, it would be 12. Daily would be 365, and then your number of years. %. So if you notice, this says percent here. So that means when you're typing this in that you actually put your percent in, not as a decimal. So that's as a percent. PV stands for what you presently have. That's a dollar amount. PMT stands for payment. So how much money you're paying into your account or how much money you're paying off of your loan. Future value stands for what you will have in the future. And that's also a dollar amount. P/Y stands for payments per year. C/Y stands for number of times interest is compounded per year. And then the last button says payment, and it says on it end or beginning. And right now, end is highlighted, and we want it to stay highlighted. Just because we're not in a really hardcore finance class. If you're in a really hardcore finance class that you could take in college, those things will change. But for our purposes, you're going to keep end highlighted. So I'm going to say leave this alone. All right. So that's it for your notes. We're going to go over examples so you can see how all of this works and see how we can solve some really cool problems that will be useful in your life, hopefully. I actually used this finance application the last time I bought a car, so I could figure out what my payments would be like, and so that the car people didn't try to make me pay more than I wanted to. So anyway, hopefully this will actually be useful to you. Have a great day. We'll see you later.